And in ratio, differences are meaningful just like interval, but it also has ratios that are meaningful, and there is also a true 0 point. And by true 0 point, what we mean there is that 0 means what we think of as 0 typically, or the absence of the property. Like 0 inches, there's no length or what have you. Okay, so an example would be weight in pounds. And here 10 pounds is twice as much as 5 pounds. Or in other words, 10 divided by 5 is 2, or it's 2 times as much. So that's a meaningful ratio. And in addition to this, 0 pounds means no weight or an absence of weight. So there's a true 0 point. So if something is 0 pounds, that means it has no weight whatsoever. Okay, so now let's compare the scales. And I think this is where you really can start to see some of the differences between these 4 scales more clearly as we really start to differentiate between them through examples. So interval versus ordinal, we'll start there. Recall that our interval example was temperature. And in that example, a 1 degree difference is the same at all points of the scale. That was our example of interval. And then for ordinal, we had the place in the race, first, second, and third. The difference in finishing between first and second now for ordinal is not necessarily, and probably is not, the same as the difference between second and third. Now you might say, well, wait a second. The difference between first and second is 1, and the difference between second and third is 1, so that should be the same as interval. But what we need to think about here is to ask yourself, let's say we're sitting there at that finish line, and the person who finishes in first and second, those two, let's say, are neck and neck. And the first place person just barely wins at the end. And then along comes third place person much later. So we have first and second neck and neck, and then third comes along later, let's say a minute later or something like that. So in this race, the difference between first and second was very small, but the difference between second and third was very large. So those aren't equal intervals among the adjacent categories. And that's why it's ordinal. So for this example, it's ordinal because we know there's order to it. First is better than second, second's better than third, but we can't say that those adjacent categories are equal. Now, if we knew the time in which each of these finished, the exact time, that would be a different example. But in this example, assume all you know is someone came in first, someone came in second, and someone came in third. Those results were written down or they were shown in the paper, and that's all you had. In that case, if that's all you know, first, second, and third, and the names of each person, that's a classic ordinal example. Okay, next, interval versus ratio. Now, the two qualities of ratio, recall, is that the ratios are meaningful and there's a true 0 point, or 0 means the absence of the property. Well, think of temperature. 0 degrees. How is it outside? If you thought of 0 degrees, you wouldn't say there's an absence of coldness or heat outside. You would say it's really cold, right? 0 degrees Fahrenheit, it's 32 degrees below the freezing point. So it's really cold. So 0 does not indicate an absence of the property there. And then in terms of the ratios, if we think back to our ratio example with the weight of objects, if I had a 5-pound object and I had another 5-pound object and I put both those on the scale, that would give me 10 pounds, right? Total weight. But if I have a 40-degree day and I have another 40-degree day, so a cold day and a cold day, and I put both of those together, I don't get suddenly a warm day, 80 degrees. A 40-degree day and a 40-degree day is still a 40-degree day. It doesn't suddenly equal an 80-degree day. So the ratio isn't meaningful there for temperature. So this is why temperature is interval and weight is ratio. Okay, and then finally, let's take a look at nominal versus ordinal, interval, and ratio. So recall with our example of baseball uniform numbers, the numbers only serve to differentiate between players. There's no order to them. 25 isn't necessarily better than 23. There's no meaningful differences. I can't subtract 25 minus 23, get a 2, and then my next number up, let's say, is 30 and 35, subtract 35 and 30 and get a 5. That doesn't even make any sense. We wouldn't subtract uniform numbers and expect to get any meaning out of that. And then ratios are not meaningful and there's no true 0 point. Think of someone who chose the number 0 in baseball. That doesn't mean there's an absence of a baseball player there, right? 0 means nothing. That would just be a player with the number 0. So that's why baseball wouldn't be ordinal, interval, or ratio. All right, that's it for scales of measurement. Thanks for watching.